One other thing that we're going to talk about this first week in Chapter 12 is we're going to review some of the key algebra concepts you'll have to be able to use in this chapter. And this is something that's not new to you. It's things you learned in Algebra 1, but it's worthwhile reviewing because they come up so often. First one, when you have a number outside of a parenthesis and you're to multiply those together, you have to distribute, it's called. It means you have to take that number and multiply it by each thing inside there. 6 times the x, 6x. 6 times the -3, -18. And that would be our answer when we distribute there. Not anything that's new. In fact, we've used that quite a bit. Another concept that shows up a lot in this chapter is multiplying two binomials together. Some of you may have learned this using a little acronym, FOIL, FOIL. It stands for first, outside, inside, last. First means the first one in the left parenthesis times the first one in the right. X times x is x squared. Outside means the ones that are furthest away from each other. The x times the -4, -4x. The inside means the two closest ones, the middle ones. +5 times x, +5x. And the L stands for the last one in the first group times the last one in the second group. 5 times -4, -20. You can see that these two middle ones are like terms, so we'll combine those. -4x plus 5x is 1x. And this would be our answer when we multiply those together. Again, there'll be quite a few instances where we have to use multiplying two binomials in this chapter. This next one is squaring a binomial. When we square something, it means we multiply it times itself. So it means we have an x plus 3 multiplied by another x plus 3. And then we use that same FOIL process we just reviewed. First times first, x times x being x squared. Outsides, x times 3, 3x. Insides, 3 times x, another 3x. Last, 3 times 3 is 9. And as we saw in the problem before this, we have like terms in the middle. X squared plus 6x plus 9. Squaring anything means to take it times itself. Let's practice another one of those. If we wish to square x minus 4, it means we have an x minus 4 multiplied by another x minus 4. Using our FOIL process, first times first is x squared. Outsides, -4x. Insides, another -4x. And last, +16. And yet again, combining those like terms in the middle, -8x. There is our answer. Let's try a squaring of a binomial where we have a leading number that's not just a leading term that's not just an x. It's done in exactly the same manner. If we wish to square a 2x minus 5, it means we have a 2x minus 5 times a second 2x minus 5. That's what squaring means. And then we follow our FOIL process. 2x times 2x, 4x squared. 2x times -5, -10x. -5 times 2x, another -10x. -5 times -5, +25. Combining those two like terms in the middle, 4x squared minus 20x plus 25. Let's talk about solving quadratic equations. There actually are 3 methods for solving quadratic equations you're taught in Algebra 1. We're going to review all 3 of them. The first of them is called using square roots. To solve by using square roots, we follow the process of isolating the squared term. That means we want to get the thing that's squared by itself. Second step, we take the square root of both sides. And then the third step is we finish solving. Now, sometimes we don't even have that third step. When you look at this problem, the squared term is already isolated. It's by itself. So we immediately take the square root of both sides. That's going to give us two answers. The square root of 64 could be positive 8, and it could be negative 8. Both of those are valid algebra answers. In geometry, both answers don't always work. Sometimes only one works. Sometimes they both work. Let's do a few more solving by using square roots. First step, we're going to isolate the squared term. Well, that means I have to divide by 3. X squared equals 27. The second step, we're going to take the square root of both sides. And you'll always get two answers here. Oh, when I divided 27 by 3, I should have gotten 9. We take the square root of both sides. We get x equals positive 3 and x equals negative 3. Both of those are valid algebra answers. Now, you may have been taught back in Algebra 1 to use a plus or minus sign. In geometry, we do not use a plus-minus sign. And you'll see why as we go along in this review. Let's do yet another one, solving by using square roots. Our first step is to isolate. Now, to isolate, we're going to remove the 2. So we'll divide by 2 on both sides. X minus 7 squared equals 36. Then we'll take the square root of both sides. That leaves us with x minus 7 equals 6, and x minus 7 equals negative 6. And now we'll finish solving. Add 7 on both sides. We get x equals 13. Add 7 on both sides here. We get x equals 1. This type of problem is the main reason we do not use the plus or minus signs in geometry. Let's move on to a second type of solving quadratics you learned in Algebra 1. This is called solving by factoring. To solve by factoring, we must set it equal to 0. So we have to set the equation equal to 0. We'll do that by subtracting a 17 on both sides. X squared minus 12x, and then plus 32 equals 0. This one is called a general trinomial. There is no common factor to factor out, so we make 2 sets of parentheses. The first 2 have to multiply to give us x squared. Well, not a lot of choices there, x and x. The last 2 have to multiply to give us 32, and then they also have to add up to 12. So I think we're going to have to use 8 and 4. And to get a negative 12, we need both of them to be negative. To finish solving, we have to set each of those factors equal to 0. We'll add 8. We end up with x equals 8. We'll add 4. We end up with x equals 4. Let's do another one, solving by factoring. We have to get it so it's set equal to 0. So we'll subtract a 6 on both sides. 2x squared plus x minus 15 equals 0. Another general trinomial. So we'll make two sets of parentheses. This time the front two have to multiply to give us x squared. Or rather, multiply to 2x squared this time. We'll need a 2x and an x. The back ones have to multiply to give us 15, and they have to subtract to give us 1. And at first that might not seem possible. But I think if we place a 3 here, and we place a 5 here, we can see that on the inside we get a 5x, and on the outside we get a 6x, and that will in fact subtract to give us 1x. Now if we want to have a positive 1x, we'll have to put a plus here and a minus there. We set each of those factors equal to 0. This one we'll add 5 and divide by 2. The other one will just subtract 3. A little bit harder factoring, but again, you learned this in Algebra 1, so this is review. The last type of solving for quadratic equations that I want to go through with you is the quadratic formula. The quadratic formula was a formula you memorized. It was x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. We still have to set this equal to 0, so we'll subtract a 6 on both sides. 3x squared plus 2x minus 7 equals 0. I want to remind you that the a is the first term, so in this case a is 3. The b is the second term, so the b is 2. And the c is the constant, so c is negative 7. We'll go ahead and put that into our quadratic formula. X equals the negative of b plus or minus the square root, and then b squared minus 4 times the a times the c, all divided by 2 times the a. When we work out what's beneath that square root sign, that's called the radicand, we get an 88 under there. And actually, there are two answers. One answer is when we use the minus sign, negative 2 minus the square root of 88, all over 6. The other is when we use the plus sign, negative 2 plus the square root of 88, all over 6. It asks us to round to the nearest tenth. When you put this into your calculator, do not forget, you'll need to put a parenthesis around the whole top on each one of these. So the top one, to the nearest tenth, comes out to be negative 1.9. The bottom one comes out to be positive 1.2. And yes, you will have to know that formula. Okay. Hopefully this review will help you. We'll use all of these techniques throughout this chapter. Best of luck on this. I didn't put any specific algebra practice because it'll show up in our work as we go through the chapter. Just the notes on this.